Welcome to the Crazy Hat Chemist. So another video in gases. Bam! So today we are doing a manometer problem. So I want you to take a close look at that diagram on the left-hand side. We're going to come back to that here in just a second. I'm going to read what's on the right-hand side for you. A laboratory barometer, that's not a manometer, but a laboratory barometer reads an atmospheric pressure of 762.1 torr. A sample of gas is placed in a flask attached to an open-end mercury manometer. See diagram. A meter stick is used to measure the height of the mercury in the two arms of the U-tube. What is the pressure of the gas in the flask in atmospheres and in kilopascals? So take a look at that diagram. You have that round bottom flask on the upper left-hand corner of the diagram. We're trying to get the pressure of that gas right there. The right-hand side of the U-tube is open to the atmosphere there, so there's atmosphere that's pushing down on that. Okay, we can get that atmospheric pressure from that 762.1 torr. Okay, then a meter stick is used on the right-hand side of that U-tube to measure 143.5 millimeters of mercury. A meter stick is used on the left-hand side of the U-tube at 93.8 millimeters of mercury. So you should see that there's atmospheric pressure pushing down on that U-tube, and yet there's gas inside the flask. And since the U-tube mercury is higher on the right-hand side, that means the pressure in the flask is greater than that of the atmospheric pressure. So what are we trying to solve for? We're actually trying to solve for the difference between these two heights here, using the atmospheric pressure. Okay, so let's see if we can work this out in the problem, and then we're also going to do a little bit of unit conversion here between atmospheres and kilopascals at the end. All right, let's give it a try. Okay, so the pressure of the gas in the flask is equal to the atmospheric pressure plus X. X is the difference between the two heights on the right and left of the U-tube. Okay, we were given the atmospheric pressure, okay, and then we are going to solve for that X value right there, which is the difference in the heights. So the atmospheric pressure was 762.1 torr, and the height on the right-hand side was 143.5 torr, and the height on the left-hand side of the U-tube was 93.8 torr. We're going to take the difference there, then we're going to sum those numbers up, and we're going to get the 811.8 torr. Okay, now what we need to do is convert this into the correct units that were asked in the problem, which was atmospheres and kilopascals, I believe. So we're going to change this from torr into atmospheres. Okay, and the unit conversion between torr and atmospheres is 1 atmosphere is equal to 760 torr. All right, there's an infinite number of significant figures in the number 1 and an infinite number of significant figures in the 760 because this is a unit conversion. It's kind of like 1 inch equals 2.54 centimeters. 1 inch has an infinite number of significant figures, and 2.54 centimeters has an infinite number of significant figures. Again, this is because it's a unit conversion, not because we measured it. So ultimately, we're going to be using the 4 significant figures that we had originally in the problem. And this will convert our atmospheres now, our torr rather, into atmospheres at 1.068 atmospheres. All right, now what we're going to do is convert this into kilopascals. So we can take that 1.068 atmospheres and use the unit conversion with atmospheres and kilopascals. Or we could have taken originally the 811.8 torr and used the conversion between torr and kilopascals, and you should see that you're getting actually the same numeric value for the kilopascals. Remember, you're just multiplying. When you're doing unit conversions, you're just multiplying by a factor or dividing by a factor. All you're doing is changing the units, but you're actually not changing the amount or the value of that, what you have, right? If you have $1, it's equal to 4 quarters. They're the same. It's equal to 10 dimes. It's equal to 100 pennies. It doesn't matter, okay? All right, so hopefully that manometer problem worked out well for you. And I got a crazy hat for you. This is a Dr. Seuss hat. Give me a thumbs up if you like that video. Subscribe to my YouTube channel and read some Dr. Seuss books. They're lots of fun. Bye now. Have a great day.